So, your finished product here with our notes is going to be a 5-branch tree map that looks like this. The title is called Angle Relationships, but we're going to go one at a time. So, the title of that tree map, let's go ahead and do that first. Going to write the words angle relationships right on top. Again, this is for you. You're not turning this into me. I can care less about your notes. Your notes are for you for reference to use on quizzes, assignments, and tests. Right there on top. That's the title of the tree map. Right on top. Angle relationships. Angle relationships is the title of the tree map. All right. Notice the word relationships. In order for a relationship to be realized, you need two or more of a thing. So, in order for a relationship among people to exist, there has to be two or more people, two or more of something. Well, I'm going to throw a bunch of relationships of angles which involve two or more angles. I'm going to throw 5 at you right now. The first one is going to be called, ready? Adjacent angles. Write that down. And notice I gave you a lot of space there because we're going to draw pictures of each one. Adjacent angles. Angles right next to each other that share a common vertex and side. Angles right next to each other that share a common vertex and side. Angles right next to each other that share a common vertex and side. We're going to draw a picture of those right now after we're done writing this. Okay, so let's see. Two angles that share a common vertex and side. They're right next to each other. I'll use Green Bay Packers green for right now, since that's this day in history. Watch this. There's two angles right next to each other. I'll call this angle 1. I'll call this angle 2.
Can we draw that?
Yes, please. I gave you a lot of space there to draw a picture. So those are two adjacent angles. Let's call this point A here. And let's call this point C. So the adjacent angles here are the two angles. They're right next to each other. Obviously, angle 1 and angle 2 are right next to each other. They share a common vertex, which is point A, notice. And they share a common side. The ray AC, notice this ray, they share it. So go to write angle 1 and angle 2 are adjacent. And this word adjacent, we kind of use this, it's pretty common in English, just English conversation. Things that are adjacent are things that are right next to each other. For instance, the teacher that's to the left of me over here, who's this teacher? Rios. So Rios and I are adjacent to each other. We're right next to each other. We share this wall. That's how we use it in the English language. Me and Robles over here share that wall. We're adjacent. Our rooms are adjacent. The hallway is adjacent to my room. So it's just a fancy schmancy word that means right next to each other. So angle 1 and angle 2 are adjacent. That's all it means. All right, the second and third branch, we're going to just write together because they're very related and they sound the same. Going to write the second and third branches. We've got complementary angles, supplementary angles. You probably have seen this before. This should be reviewed. Complementary angles, supplementary angles. Coffee's good. Angles that add up to be 90 degrees. Each angle is a complement of the other. Let's draw some. I'm going to draw two angles that are complements of each other. Very basic. Watch this. Let's say this is a 50-degree angle and a 90-degree angle. How about that? Or a 40-degree angle, rather. One angle is 50, one angle is 40. Add those puppies up, you get 90 degrees. They're complementary. In other words, if you put them together, they form a right angle. We call them complementary angles. So if I were to put the angles together, even though I got crappy artistic skills, they kind of form a right angle, sort of. That's a 90-degree angle. I just estimated 50 and 40 added to be 90. Complementary. Supplementary is two angles added to be 180. Each one is a supplement of the other. I mean, it's straightforward. You've seen this before, I'm confident. I'll draw, for a supplementary, I'll draw a 50-degree angle. And then I'll draw a 130-degree angle. 130 degrees. Add those puppies up, you're going to get 180. Supplementary. If I put the angles together, you'll see they form a straight angle. In other words, 130 degrees or 180 degrees if I put them together. Supplementary. Thumbs away right now? There's thumbs up. So far, so good. 3 down, 2 to go. 2 to go. So we're on our fourth branch. The fourth one is called vertical angles. Two angles formed by two intersecting lines, they are always congruent. Two angles formed by two intersecting lines, they're always congruent. So we're going to draw two lines intersecting. These are vertical angles. Two angles formed by two intersecting lines, they are always congruent. We talked about congruency yesterday. That weird word that we typically only use in math. Who won the stamps, by the way, when I... That's right, Aliaga got it. So congruent, remember, congruent means same measure. They're not the same angle, but the same measure. And here they're saying two angles formed by two intersecting lines. There's actually four angles, though. These two are vertical. I'm going to put like a little hash mark with a tick. That little arc with a tick mark. That's communicating that those two angles are the same measure. And then these two are also the same measure. Vertical angles. Let's call this angle 1, let's call this angle 2. We'll call this angle 3, we'll call this angle 4. So, this is telling us this relationship is, I'll compose. This relationship says, look, angle 1 is going to be congruent to angle 2 all the time. All the time. We're in the fourth branch right here. The fourth one. And angle 3 is going to be congruent to angle 4 all the time. Remember that congruent symbol? The equal with a tilde over it. My cheesy example that I'm showing to my students is the example of scissors. I'll wait till you guys are done writing that. Go ahead and write that. We're ready for the last relationship, which is linear pair. Last one. Linear pair. Two adjacent angles that are supplementary. Their non-common sides form a line. Notice as you're writing this definition, the definition assumes you already know two words we've covered in this tree map. Adjacent and supplementary. It's assuming you know how to do that or understand those definitions. Two adjacent. We covered adjacent. Angles that are supplementary. That's the third branch, the first and third branch. Their non-common sides form a line. Go ahead and draw the picture there. All right, so two adjacent angles. Notice angle 1 and 2 are adjacent because they're right next to each other. That was the definition of adjacent. They're supplementary. What does supplementary mean, Varela? Exactly. That means 1 and 2 both add up to be 180, which is pretty obvious. You can see they're a straight angle if you add those puppies up. So let's go to write that as our a small equation to remind us of their supplementary nature. So I'm going to write the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And they're called a pair, a kind of pair, linear. Linear. The word linear has the word line in it, right? Linear, linear. Because angle 1 and angle 2, their non-common sides form a line. The non-common sides, I'm going to go and highlight with Dodger blue. The non-common sides would be this ray, they don't share that side. And this ray, they don't share that ray. They're the non-common sides, they don't share them. They form a line. Notice what I highlighted in blue forms a line, hence the name linear pair. There's no mystery to it. Linear pair, linear pair. That's two of them. That's angle relationships. Pretty straightforward note session today. What we're going to do now is I'm going to put you guys in groups of 2 for a small table talk. Okay.